Hey guys, it's Miss Jenkins. I just want to check in on you before we get our lesson started. How is it going? We've been in this for a few days now, and I know it's not easy. If you just want to talk or anything, please feel free to message me. I want to make sure you guys are doing okay. I know it's hard on all of us, but please, just let me know how you're doing. Okay, so before we get started, I'll say we're going to do this warm-up just like we've been doing. I know it's not super exciting and probably less fun to do at your own house. So I'm going to write that formula for area of a trapezoid again. So area of a trapezoid is 1/2 height times base 1 plus base 2. Here, in our first example, we have area equals 1/2. My height, you see, is that 12 times base 1 plus base 2, so 12 plus 15. 12 plus 15 should give me 27. Double check my math. And then half of 12 is 6. So I'm going to rewrite this as 6 times 27. And we know that 6 times 27 is going to be 162 meters squared. Okay, let's try the next one. Okay, we're going to be using the same information for the second one. Now you just notice the trapezoid is on its side. So you still have area equals 1/2. And then our height now, again, it's what joins those parallel bases. So it says 28 times 20 plus 35. Well, 20 plus 35 is 55. And we know that half of 28 is going to be 14. So area equals 14 times 55. And if I put that in my calculator, I get 770 inches squared. Okay. And the next two are word problems. So a trapezoid has an area of 125 square centimeters. The length of the bases are 8 and 17. Find the height. So we know that area equals 1/2 height base 1 plus base 2. Area here is 125, so I'm going to fill in what I know. Equals 1/2. We're trying to find that height. And then my two bases are 8 plus 17. I know I'm close to the edge, I'm sorry. So that gives me 125 equals 1/2. 8 plus 17, it's going to give me 25. Times my height. I have a couple options here. I can multiply 2 to the other side and then divide by 25. I could take 1/2 of 25, and that would probably be my first step. So half of 25, again using your calculator, it's going to be 12.5 H equals 125. Divide by 12.5, divide by 12.5, and we see that our height is going to be 10 centimeters. So height of 10 centimeters. I'm going to try to get the rest of this to fit underneath the next one. So we have, again, an area of 180. The height here is 20 feet, and one of the bases is 10 feet. So we want to find the other base. So this one's a little bit more complicated, just like that one from yesterday. So we have 190 feet squared equals, it's okay if you guys just add those in at the end. If it's area, you know it's going to be whatever the unit is squared. If you're looking for length, you know it's just going to be whatever the unit is. So 190 feet squared equals 1/2 my height of 20. And then I have base 1 of 10 feet plus base 2. Okay, so if I look at this, I know that half of 20 is going to be 10. So I can rewrite this. I'm going to sneeze. Give me 1 second, guys. I'm going to pause the video. Sorry for that break. Okay, so this, when we rewrite it, is 190 equals 10 times 10 plus base 1. You can either distribute the 10, subtract it over, or what you can do is just divide by 10 first. So we're going to divide by 10 on both sides. We divide by 10. Let me find a different color. See, the zeros cancel because they're both divisible by 10, so we end up with 19 equals 10 plus B1. Get B1 by itself, subtract 10. So we see here 19 minus 10 is just 9. So our length of B1 is going to be 9. And then what's my units on this? Feet. 9 feet. Okay. Okay, 8.7 is the last one in this chapter. So 8.7 is circumference and area of circles. You guys have dealt a little bit with circles before, so we're going to talk a little bit more about them. So to find the circumference and area of a circle is what we're talking about today. Circumference and area of a circle. So you guys might want to pause these to make sure you get your definitions down. I'll try to give you a few seconds. So your first definition is a circle, a set of all points in a plane that are the same distance from a given point. A circle with the center P is called circle P, or you see this little dot with a circle with a dot in the middle of it and then P. It's the shorthand. Radius is the distance from the center of the circle to one point on the circle. And then when we say radius, when it's plural, we call it radii with two i's at the end. Again, if you need to pause it, feel free to. We also have the vocab word of diameter. That's the distance across the circle through the center. The diameter is twice the distance of the radius. So this part here is very important. The diameter equals 2 times the radius. Circumference is the distance around the circle. So when we draw circles, so I might actually get to use this and it might actually make a circle. Let's see if I can do it. So you see that we have a circle here. The circumference is the red part. It would be like the perimeter of a circle if we were calling it a perimeter. So how long is that around it? How much fencing would you need to fence in a circular patch of ground? So that's what we're talking about today. Circumference is the distance around a circle. Okay, and then we have this nice picture. So you see circumference is in blue. It's talking about that blue distance around. The radius here is in red. It's that distance from the center all the way to the edge of the circle. It will be the same no matter where you're at in the circle. And the diameter goes straight through the center and then cuts the circle directly in half. There are technically infinitely many diameters of a circle. Okay, so now we have this formula for circumference. So to find the circumference, to find that distance around a circle, you can either use pi d or 2 pi r. So remember, 2r is the same thing as d, so the diameter. So just make sure you're keeping that in mind. Either of those work. So for this one, since we're given the radius, and you see that the radius is 7, the formula that's more convenient is going to be that 2 pi r. So to find circumference, we could just do 2 times our 7 meters times pi, which gives me 14 pi meters. That's the exact answer, or you can give me the approximation. So remember, approximation would do that little curvy equal sign, and that would be 43.96 once you put in your calculator. There's a pi button on your calculator to give you the most accurate answer. Our next one up will be example 1. So let me switch our slide. So once again, we have those same formulas. Circumference equals 2 pi r, or circumference equals pi d. So in the first one, again, we have the radius, which is 2 inches. So the one that's most convenient is the one that has a radius in it. So circumference equals 2 pi times 2 inches. The exact answer would be 2 times 2, which is 4 pi inches. This is not an area, so these units should not be squared. This is approximately, if you put it in your calculator, 12.56 inches. So this is like the perimeter of the circle. Remember that. This is, again, a radius. So we're going to use circumference equals 2 pi r. 2 pi, my radius here is that 11 centimeters. So exact answer would be 2 times 11, 22 pi centimeters. If you put that into your calculator, that's going to give you approximately 69.08 centimeters. Okay, and then our last one here for this group is that this has a diameter, so the one that's more convenient for us to use is going to be pi d. Again, if you wanted to find the radius, it would just be the diameter of 28 divided by 2, and that would work out the same way. But we have the diameter already, so there's no sense of changing it. So it would be times 28 yards. So we could rewrite this as 28 pi yards, which is approximately 87.92 yards. Okay, so we're going to switch to area of a circle next. Slightly different formula. Okay, so now we're on to area of the circle. So how much is on the inside of a circle? So that's how much, I don't know, carpeting you'd need if you had a circular room. Or if you wanted just buy sod to grass in a circular area. I'm not exactly sure why you'd do that. But these are just some examples. Maybe more accurate would be like people painting something that's circular. So if you're painting a table, how much area would you have on that table? So that is a circle's one thing is area equals pi r squared. This is probably the more famous formula that you know. There's a math joke that goes with this. So people say pi r squared, and then you're supposed to say no, pi r round, because pi is round. I'm not saying it was a good joke, but it's a joke. You probably have heard it before. So here, this example says to find the area, you do pi and then r squared. So here it's 6 feet squared. So that'd become 6 feet times 6 feet, which is 36 feet. So pi times 36 feet squared. You can rewrite this as 36 pi feet squared. Or you can put in your calculator for an approximation of approximately 113.04 feet squared. So that was like the example of how to use the formula, but these are like the actual examples. This section is just filled with a lot of them. So we're going to do this again. Area equals pi r squared. So our r here is that 17. So pi r squared, 17 inches squared. If you have your calculator, I'll get mine. By calculator, I definitely mean cell phone. So 17 times 17 is 289 pi inches squared. And then if you times that by your pi button, you should end up with something like 907.46 inches squared. It's a pretty big number. Over here, we have it again. Area equals pi r squared. Your r is that 5. So that is the radius. So pi times 5 centimeters squared gives me 25 pi centimeters squared. So 25 times pi, that's approximately 78.5 centimeters squared. Okay, and then the last one has a diameter in it. Well, the area formula has to be in reference to a radius. So remember, to find the radius, you're just going to do diameter divided by 2. So our diameter here is 2 meters. So divided by 2 gives you 1 meter. So area equals pi r, 1 meter squared. Well, that gives me 1 pi meter squared. Well, we know pi is approximately, let's use my approximation sign again, 3.14 meters squared. Okay, so this is how we do area. So remember, circumference is like the perimeter of a circle, and that's either going to be 2 pi r, or it's going to be pi d. And then for area, it's pi r squared. Okay, now we're going to move on to 2 more definitions. So we have find the area of a sector, the central angle. So we have, this is how to find the area of a sector, I should say. So the definition of a central angle is the angle whose vertex is the center of the circle. So you see that example here. We have our vertex at the center of the circle. And then the sector is the region of the circle determined by 2 radii and part of the circle. So here, the area of the circle is that little chunk inside the red. So we just want to now find part of the area, and not the whole circle's area, just part of it. Pause it if you need to. I'm going to switch to the next slide. Okay, and then this is the important part here. We can use the following proportion to solve. So area of the sector is over area of the entire circle equals the measure of the central angle over the measure of the entire circle. So the interior of a circle's measure is always going to be 360 degrees. So if you guys don't remember that, let's just make sure I tell you now. So that part's always going to be 360. And this is what we're going to use to solve the rest of them. It's going to be a little hard for me to rewrite on the next slide. So please make sure that you guys have this on your page so I can reference it without me having to rewrite it. Okay, so for our last 2 examples, it says you want to find the area of the shaded sector. So based on those two formulas, area of the shaded sector was the x in the numerator of the first fraction. And then in the denominator is area of the entire circle. So we had to find the area of the entire circle. So area equals pi r squared. Well, here we know that my r is that 5. So I can do pi times 5. It's a rough looking pi, isn't it? 5 meters squared. That gives me 25 pi meters squared. If you put this into your calculator, it's going to give you approximately 78.5 is what I got. 78.5 meters squared, which is equal to, and then you put the degree of the sector, so the shaded region, that's 150, and then remember we always put it over our total, which is 360. That's always going to be 360. You have two options. You can just go for multiplying, but right here I can see an easy reducing. They both end in 0, so it means they're divisible by 10. So I'm going to cross multiply here, and I get 36x equals, and then we end up with 78.5 times 15. Ooh. Times 15. I got 1,177.5. And then I'm going to divide each side by 36 to isolate that x. That's that area of a sector. It's divided by 36. And that gives me 32.708. So I'm going to put 1. And this was in meters squared because it's still area. So whatever the unit was, make sure you square it. So on the next one it says the same directions. Find the area of the sector. So remember it's area of the sector over total. So I'm going to leave that x there. So the total area is area equals pi r squared. Pi, my r is again that 7, that's my radius, 7 centimeters squared. That gives me 49 pi centimeters squared. I'm going to try 49 times my pi. That's 153.86 approximately. So 153.86. And then you have the area, the degree of the sector, that's 100 over the total degree, which is going to stay at 360. Again, we can reduce. We can take out the zeros. We can go a little bit further. 2 goes into both of these. This becomes 5. This becomes 18. We can cross multiply. And with 18x equals 5 times 153.86. Again, you didn't have to do that, guys. You could have chosen to just multiply as is. They'd just be bigger numbers, so it's not really the end of the world. It just makes it a little easier for me to deal with these. So let's go here. We have 5 times 153.86. And then we're going to get 118 equals, nope, it's just 18 equals x. 18x equals 76.9.3. It's very weird for me to be sitting at home doing this math without you guys being able to see me and me see you guys. I miss you. I really, really hope that you're staying safe and making good decisions. Remember, when you guys are washing your hands, you're supposed to sing happy birthday twice. They claim that's the #1 defense against this. And even though your age group is not a huge group that's getting infected, you are the carriers to the other groups. So you guys have to stay healthy and make sure you're not getting this. So please, please, please stay safe. Make good decisions. Wash your hands. Let me know if you have any questions. I miss you guys.